Now let's see, as I told you, we will revisit this linear Boolean function. We have already seen what is linear Boolean function. We have already seen linear function. This definition we have already seen. Now we need to see some more important points. Okay. Some small points I did not tell you. Now let's see those points. We have already seen the definition of linear function. See, this is the definition of linear function. When can I say a Boolean function is linear? This is the definition on your screen. A Boolean function is linear if one of the following two statements is true. If one of the following two statement is true, either this should happen or this should happen. Okay, what this is saying? For every f equal to 1 row, the number of ones in the input is odd, and for every f equal to 0 row, number of ones in the input is even. Or what should happen? For every f equal to 1 row, the number of ones in the input is even, and for every f equal to 0 row, number of ones in the input is odd. This definition and examples we have already seen. But I want to tell you one important point, and this is very important, let me tell you. That is, before you check if a function is linear or not, first you minimize it. Is this clear? Before you check this function is linear or not, you must minimize it. You must minimize it. Okay. So this is what I'm telling you. Before you apply this definition, before you check f is linear or not, okay, first you must minimize f. Okay, so remember this point. First, minimize f, then check is it linear or not. First you minimize f. Okay, first you minimize f, then apply linear definition. Then apply this, or I can say, then check is it linear or not. Then check f is linear or not. Okay, so this is important. First you minimize. This is very important. Okay, see, let me tell you why. What are the reason? Why? What are the reason? Let me tell you. First of all, consider this function f equal to simply a. Okay, see, now if I simply give you a, is this monotone or not? If I simply give you this f equal to a, if I simply give you, is this monotonic or not? Sorry, linear. Is this linear or not? This function, is it linear or not? Please tell me. I give you f equal to a. Is it linear or not? Let me know. Is this function linear or not? Look at this function. Apply the definition of linear function. Is this linear or not? See, here you can notice that it is linear. Yes or no? Here you can notice why it is linear. F is linear because, notice here what is happening. For all f equal to 1 rows. Okay, for all f equal to 1 rows. What is happening for all f equal to 1 rows? For all f equal to 1 rows. Let me know. For all f equal to 1 rows, what is happening? Whenever f is equal to 1, in those rows, number of ones in the input is odd. Yes or no? Odd ones in the input. Odd ones in input. And for all f equal to 0 rows, what is happening? Please tell me. For all f equal to 0 rows. For all f equal to 0 rows, what is happening? Let me know. You can see whenever f equal to 0, then you have even number of ones in the input. So the definition is fine. Yes or no? Definition is satisfied or not? Please tell me. So you can see. So the definition is satisfied. Yes, agree. So you can see the definition is satisfied. So finally I can say that this f equal to a is linear. Is linear. Yes or no? Is this clear? Did you understand this? Because you can notice for all f equal to 1, for all f equal to 1 rows, input has odd number of ones, and for all f equal to 0 rows, input has even number of ones. So this function is linear. Yes or no? Agree with me? Please tell me. This function is linear. Yes or no? F equal to a is linear. So this function, this is a linear. Now notice something interesting. If you don't minimize, okay, if you don't minimize, for example, can I write the same function in the exam? Can they give you the same function like a or ab? We already know a or ab, that is same as a. See, a or ab, that is same as a. Yes or no? A or ab, that is same as a. We already know. This is called absorption property. This is called absorption law. We already know this. Now you tell me, if you don't minimize it, Remember, this is same as A. Remember, this is same as A. So this would be linear or not? Please tell me. Remember, this is same as A. This is the same as A. This is same as A. So this should be linear because this is equal to A. This is equal to A. So this should be linear. But without minimizing, if you check, then what will happen? See, without minimizing, if you check, what will happen? You did not minimize. You did not minimize. Now you are checking. Now what will happen? This is the truth table. Now you tell me, whenever f is 1, how many ones are there in the input? Now notice. Look at f equal to 1 rows. Look at f equal to 1 rows. Tell me how many ones in the input? How many ones in the input? Sometimes even number of ones, sometimes odd number of ones. Yes or no? Can you notice? Sometimes even number of ones, sometimes odd number of ones. Sometimes even number of ones in input, and sometimes odd number of ones in input. Is this clear? Sometimes even number of ones in input, sometimes odd ones in input. Understood? Please tell me. So without minimizing, if you directly check, then what your answer will be? If without minimizing, you directly check it, then what your answer will be? Without minimizing, if you directly check, what your answer will be? Your answer will be not linear. But this is linear. But this is linear because these are same. Okay, these are same and A is linear. So remember this point. Please understand that FAB equal to A or AB. A or AB. This is equal to A. This is a linear. This is a linear. So of course this is also linear. So of course this is also linear because they are same. Because they are same. So both are linear. Okay. But first minimize it. Is this clear? Okay. So very simple. First minimize. Then check is it linear or not. First minimize. Minimize it. Okay. First minimize. So first you minimize, you will get A. Then check. Then check. Then you can notice this A is a linear. Okay. Is this clear? See what is happening here. Let me tell you. Let me tell you actually what is happening here. If you look at this function, FAB equal to A or AB, if you look at this function, actually this B is a dummy variable, right? See, this B is a dummy variable. Because if you look at this does not depend on B. Can I say this does not depend on B? Please tell me. Can you notice this does not depend on B? Yes or no? Because this is actually equal to A. This does not depend on B. Here, this B is called a dummy variable. This is just a dummy variable. It looks like that this is there, but it is not there. Yes or no? It looks like it is there, but it is not there. This B is a dummy variable. This is called a dummy variable. Is this clear? This type of variable is called a dummy variable. This B is actually called dummy variable. Okay? Yes or no? Because this does not depend on B. If you minimize, you will see. If you minimize it, you will see that this F does not depend on B. I can say this F does not depend on B. Okay, so that is the reason I can say this B is called dummy variable. So first you remove the dummy variable and then you apply, then you see the definition. Okay, so this is also given in the post paper. You can see the source, that is Emil post paper. Okay, so you can see this is taken from Emil post paper. Let me tell you, you can see here. You can see here. First delete dummy variables. Read this. This is taken from post original paper. Post Emil post paper. You can see. First delete dummy variables. Is this clear? First delete dummy variables. Let me tell you, this post called this linear function as counting function. Okay, this linear function, this linear Boolean function, post called it alternating function. This linear Boolean function, let me tell you, this linear Boolean function, what post called it? This Emil post. Emil post called it alternating function. Okay, Emil post named it alternating function. You can see here, alternating function. Okay, so This Emil Post named it alternating function. Alternating function. Okay. Some people call it counting function. Some authors, some few authors, very rare. Okay. Very rarely it is called, but the point is, I can say one author calls it counting function. I can say, okay, one author called it counting function. Called it counting function. Okay, but all these are same. Okay, all these things are same. Okay, there is no difference. Linear Boolean function, Emil Post called it alternating function. One author called it counting function, but we will call it linear function. Okay, so anyway, the point, that important point is, first you delete the dummy positions. First you delete the dummy variables. Okay, and then everything is fine. You can see a function is linear if one of the following happens. Please read this. A function is linear. A function is linear if one of the following happens. In every row, whenever f is equal to 1, then you must have even number of ones in the input. And in every row where f is 0, you must have odd number of ones in the input. Or whenever f is 1, then you must have odd number of ones in the input. And whenever f is 0, then you must have even number of ones in the input. So this we have already seen. Agree with me? Agree with me? So, but before that, first you delete dummy positions. First you delete dummy variable. This is what I want to tell you. First you delete dummy variable. Is this clear? Is this clear to everyone? First to delete dummy variable. Okay, so remember this point. Please remember this point, that first to delete dummy variables. Okay, so given f, if I give you some function f, given f, to check is it linear or not? To check is it linear or not? To check is it linear or not? First delete the dummy positions. Okay, first I can say, first minimize. See, when you minimize, you will find out that all the dummy variables will be gone. First minimize f. Okay, first minimize f. Is this clear? See, when you minimize f, then all the dummy variables will be gone. The benefit is, now all dummy positions are gone. All dummy variables will be gone. All dummy variables gone. If you minimize, then all dummy variables will be gone. Only non-dummy variables will be remaining. All dummy variables gone. This is the benefit. Is this clear? All the dummy variables will be gone. So if you minimize, this is the benefit. So remember, first minimize, then, okay, then create truth table, without dummy variables. Okay, then create truth table without dummy variables. Is this clear? Then create truth table without dummy variables. So this is the point. Then create truth table without dummy variables and check linearity. And check linearity. Is this clear? Let me know. Please tell me, did you understand? Is this point clear? See, this is a simple point. If I give you any function, first you minimize it, then you create a truth table without dummy variables, and then you check whether the function is linear or not. For example, let me give you a question. Okay, consider this function f equal to a, b, c. Okay, a, b, or c. Now consider this function a bar b, or a b bar, or a b bar c. Okay, now tell me, what about this function? Is this function linear or not? Now I'm asking, is f linear or not? Is f linear or not? So first, what you will do, please tell me, is f is linear or not? What you will do, please tell me. First you will minimize, yes or no? The step one, that is minimize f. Just minimize this function f. So if you minimize this function f, what you will get? Just minimize this function f. What you will get? You can see, you can apply the absorption law. You can apply the absorption law. Okay, just apply the absorption law. Here you can apply absorption law. You can apply. Yes or no? You can apply absorption law. Okay, so first you minimize. If you minimize, you are basically getting like this. Now you can notice, basically c was dummy variable. Yes or no? C was dummy variable. Correct? This C, this was just a dummy variable. Your function does not depend on C. Your function does not depend on C. This C was just a dummy variable. Your function does not depend on C. Now what you do? Now what you do? Now you have this function f. Now this is the function f you have. Okay, remember. Now this is the function f. Now you create the truth table for this only. Okay, so now in your truth table, don't consider the dummy variable. Now you consider the truth table without dummy variable. Without dummy variable. Okay, and you can check. Now you can check this will be linear. This will be linear. Is this understood? Is this understood? So first you remove dummy variable. To remove dummy variable, we are minimizing. If you minimize, dummy variables will be gone. Then create truth table without dummy variable and check linearity. Okay, so this is the final point. This is the final note. How to check if f is linear or not. Okay, this is the final note. Let me just tell you that checking f is linear or not. F is linear or not. Okay, so how to check f is linear or not? The first point is minimize it. Is this clear? So first minimize f. First you minimize f. When you minimize f, then basically what will happen? All the dummy variables are gone. Yes or no? Then all dummy variables gone. Then all dummy variables will be gone. All dummy variables will be gone. Okay. Now, then what you do? Second what you do? Now create truth table without dummy variable. Now create truth table. Now create truth table without dummy variable. Without dummy variables. Without dummy variables. And apply the definition and check linearity. Okay. And then you know how to check linearity, that you already know. And check linearity. Okay. Then you already know how to check linearity, that you already know. Okay. So this is the complete idea. I hope you understood. Is this clear? Please tell me. So far, every point that we have seen, is that clear? And one more note. This is also given in the post paper. You can see. This is also given in the post paper, that these constant functions, these are also linear function because they don't have any dummy variable. Okay, constant function. See, if I ask you this question, look at this function and tell me, is this linear? Is linear or not? Please tell me. Read this question and solve. Is this function linear or not? Is this function linear or not? Please tell me. Will you do this? Please tell me, will you do this? If I ask you, this function is linear or not, will you do this? Will you do this? If you do this, what your answer will be? If you do this, then wrongly you are getting answer wrongly. You will get answer equal to not linear. You will get not linear answer. Yes or no? You will get not linear answer. Is this clear? If you do like this, is this clear? Please tell me. Is this clear? Wrongly you are getting that answer is not linear. Okay. Is this clear? So actually very simple. If you minimize it, first you minimize. Okay. First you minimize. Minimize. If you get this, you will get. Then without dummy variable, you create truth table. Okay. Create truth table without dummy variable. Create truth table without dummy variable. Without dummy variables. Create truth table without dummy variables. Okay. So if you create truth table without dummy variables, there is no truth table, right? Yes or no? There is no truth table at all. Okay. Now, because there is no non-dummy variable here, everything is dummy. A is also dummy, B is also dummy. So create truth table without dummy variable. Without dummy variable. Okay. So that is the reason I can say there will be no truth table to create. Okay. Yes or no? There will be no truth table to create. So that is the reason I can say, remember, this function, this constant function is linear. So this is the simple point. So this is the final point, that this constant function 0, 1 are linear. They are linear functions. Okay, these functions are linear functions. So remember this point, you remember that 0, 1, they are linear functions. Okay, 0, 1, they are linear functions. So this is the note that constant functions, constant functions 0, 1 are linear. Okay, that's it. This is your linear function. We have seen all the details. Did you understand? All the details we have seen. What is a linear function? How to check whether a given function is linear or not? We have seen what the definition of linear function, and some small points also I told you. So before you check whether a function is linear or not, you just minimize it. Yes or no? So you just minimize it. Before you check whether a function is linear or not, you just minimize it. Okay, so very simple point. So I hope you understood. So far, everything is clear. Please tell me. Actually, one thing I want to tell you, if there is something that is not clear, if you are not confident how to find a function is linear or not, okay, then one video I have already recorded, I have already uploaded. That video you can watch. Okay, but you can see in this session, I have already told you the definition of linear function. Again, I told you. Okay, so you can watch that lecture also. Okay, so is this clear? Now, if you are not confident in some topic, okay, if you are confused what is happening here, then don't worry. We will take a lot of examples. We will take all the gate computer science, all the gate electronics, all questions we will take. So don't worry about it. Okay, so just stay with me and you will understand everything. Some misconceptions also I will discuss, so don't worry about it. Okay, now let's see this topic, that is monotonic Boolean function. When can I say a Boolean function is monotonic? This is our next topic. When can I say a Boolean function is monotonic or not?